Okay, let's look over some of these problems from our Chapter 3 study guide. So a lot of Chapter 3 was talking about our exponent rules. So let's go over a couple of these problems, a couple of examples of the different rules that we could see on our upcoming test. Number 2 here. So we've got 2a times 3a. So it looks like we are multiplying. Remember, just when we are multiplying our bases, the rule for exponents takes on addition. You know, sometimes with this, you know, is it an exponent? Is it a coefficient? Remember that you're still multiplying. So here we've got a coefficient of 2, we've got a coefficient of 3. We're still going to multiply that, okay? So this is still 2 times 3, which is 6. Now, when we have bases here, like we have a base of an a and we have a base of an a, the exponent here is a 1 and the exponent here is a 1. So when we're talking about the operation of multiplication, we add these exponents. So 1 plus 1 is going to take us to a 2. So all in the same problem, you're dealing with two different operations. Just remember, the biggest thing to kind of distinct between, are we dealing with something that's a coefficient or are we dealing with something that's upstairs being an exponent, okay? Just really be careful when we're dealing with that. And number 3, we've got a lot of different variables going on with this. Biggest thing to, you know, I think it helps kind of keep, it gets a little easier if we can stay organized. So here again, let's take care of the coefficients. I've got a 3 and I've got a 3. Again, we're still dealing with multiplication, so 3 times 3 is 9. So we can only deal with stuff when they have the same base, so I'm only going to look at x's here. Okay, well, this first term had an x to the first power. The second term here had x squared. So again, these are exponents, and when we multiply, we add the exponents. So this is a 1, that's a 2, 1 plus 2 is 3. Let's look at the y's. So this has a y to the third. This doesn't have a y, so we're just going to copy down that y to the third. Don't treat it, I mean, we can say y to the 0. So 3 plus 0 is going to stay at 3. But we don't see anything, so make sure we just don't ignore it. And then lastly, we've got some z's. Sorry, I mean hit the camera. We've got some z's. I've got z to the third. I've got z squared. Again, we're multiplying, so we add 3 plus 2 is 5. And we can see that 9, oh, well, this is the only thing that has a 9, so our answer should be an A. Number 4, 4 and 5, looks like it's taken on the exponent rule, or looks like we're dividing. So remember, when we divide, we subtract our exponents. One thing I always try to, you know, one way to remember that is, I think of this division sign as a giant subtraction sign. So in the numerator, we've got a coefficient of 1. It's just like, you know, if I have a whole number of, I don't know, 7, we can write that as a fraction saying 7 over 1. Same thing when we deal with this. When we see a number in the denominator, understand that, you know, there is always a number in the numerator. All right, so we've got 1/2. We can look to simplify, always look to simplify, and 1/2 obviously doesn't reduce any further. So then we got our n's. Well, we've got n to the first over n to the first. Well, anything divided by itself is going to be a 1, or think about n to the 0. So what we're going to be left with is we have a 1 on top, 2 on bottom, and the n's will go away, or they go to a 1. So the only thing we got left here is, it looks like, going to be a 1/2. All right, number 5, dealing with a couple more, dealing with more than one variable here. Again, the more variables doesn't really complicate things. It's just kind of more of an extra step. Just make sure we stay organized. Again, dealing with the coefficients, we've got a 2 over a 3. Look to simplify that, okay? Double check in your calculator. Your calculator will simplify the fraction to its simplest terms, but 2/3 doesn't go anywhere, so I'm just going to copy 2/3 back down. Let's look at, I don't know, I say in alphabetical order. So let's look at the x's. I've got x to the third over x to the third. Well, that would mean we would be doing x to the 3 minus 3, which is 0. So the x's are just going to go to 1, or in essence, are just going to kind of go away. Let's look at the y's. So I have y to the first over y squared. So in essence, I have 1 minus 2, which is a negative 1. So remember, if negatives are upstairs, they go down. If negatives are downstairs, they get flipped back up. Or one of the easier ways to think about this, I've got 1 y on top, I've got 2 y's on the bottom. Where are there more y's? Well, there's more y's in the bottom. How many more of them are there down there? There's just 1 y down there. And z, I've got z squared on top, z squared on the bottom. Same thing, dividing a number by itself, it's just going to be 1. So those are going to go away as well. So it looks like we have 2 over 3y, and looks like C is going to give us that result. 6 and 7 looks like we have powers to powers. Remember, when we have exponents on top of other exponents, we multiply those guys. The answers aren't going to stay the same. I'm going to change this because the other example doesn't give what I want to look at either. So let's say we have a 3. We have a coefficient in here as well. Okay, so since all of this stuff, right, the 3ab inside parentheses is all being squared, every individual piece in here has to be raised to that second power. So again, this is still an exponent. So this is the same thing as saying 3 squared, which is 3 times 3, right? That's a 9. Don't see this, understanding that powers to a power will multiply. Don't say 3 times 2 and answer 6. Okay, that's a big mistake. That's usually a very common mistake. Just remember, this is an exponent. Take care of your exponent. Same thing going involved in here. We've got to raise all the stuff on the inside to the second power. So we should be left with 9, I don't know if it equals a squared, b squared. All right, so kind of similar here to number 7. That y and x to the 4th, both of those pieces need to be raised to the third power. So if we think about this y, this has an exponent of a 1. So 1 times 3, we have y to the third. Let me turn this light back on. And then we look at our x's. We've got x to the 4th. Well, the x to the 4th is being raised 3 times. So this same thing is saying x to the 4th times 3, which is 12. So we have y of 3x 12. We have an a. All right. And we've got 3 other examples here. Same rules apply. It's just looks like we've got a lot of negatives. Don't get distracted by the negatives. I would go ahead and take care of the operations first. And then if we're left with negatives, then I would start flipping. I wouldn't get really flip happy in here and start, just rotating everything around, because you may not even have to do it in the end. So take care of the operation. And then if you're still left with negatives, again, if you have a negative in the bottom, it's going to go to the top. If you have a negative in the top, it's going to flip to the bottom. All right, here we go. Let's look at some coefficients. So I've got a coefficient of 1 here, a coefficient of -2. 1 times -2 is a -2. Let's look at my m's. This has an exponent of a 1. That has an exponent of a -2. Well, 1 plus -2 says I have m to the -1st. And lastly, I have n to the -3. I have n to the 2nd. -3 plus 2 is a -1. All right, so this is what I'm dealing with. Again, if we, every number can be written as a fraction, so that we didn't put anything in the basement yet, so I'm just gonna put a 1, so we know something is down there. Now, we can, in simplest form, it does not have a negative exponent. This, obviously, we still have a negative exponent, so we need to take care of it. Now, the -2. Okay, this coefficient, another coefficient was a -1. The exponent is positive. The exponent is still a +1. So, he's positive, he's happy, leave him alone. We're going to keep this upstairs, okay? So right now we have a -2 over 1. M, that has a negative exponent. It's in a numerator. What we're going to do is we're going to flip him downstairs, and now he becomes a positive. So we could have a +1. Same is going to go with the n. This is in a numerator. It's a negative. We need to flip it. So it's going to go to the denominator and go to a positive. right? So then we look at our results. Well, we've got the negative input on the outside of the fraction. Just remember, the negative, it's not in the numerator, it's not in the denominator. In essence, the whole fraction is a negative. So don't get discouraged where the negative exists. So we have 2 over nm or mn. It doesn't matter how those are affected. Number 9. Same issue going on. Don't get flip happy, or there's really nothing much we can do here. 2/3, they're both positive. They don't anything we can flip. 2/3 can't simplify, so we're just going to leave it at 2 over 3. X's, we have x over x. That's going to go away. Nothing we can do about it. And then there's no other y to combine with, but we understand that it's a negative and it's in the denominator. Negative in the bottom, we need to flip to the top. And now he becomes a positive. So we have 2y to the third over 3. Really not a whole lot going on there. 10 might get a little bit tricky here. So again, just take it piece by piece. You can't, combine a coefficient with a different variable or different variables together. So we just got to take it piece by piece. So this -3 needs to be raised to the negative first power. So I've got -3 to the -1. Let's look at the v. I've got a v to the first power to a power we multiply. 1 times -1 says we have v to the -1. And lastly, I've got a u. U is being raised to a -2, being raised to a -1. When we multiply, -2 times -1 is a +2. All right, again, we put everything on the same line here, so just understand that all of this is being divided by 1. I think it helps kind of see the fraction. So now we're going to start flipping. I'm just going to keep my bar there. This -3 is being raised to the negative first power. It's a negative, so I've got to flip him downstairs, right, since he was upstairs. So now I have a -3 to the first power. Well, anything raised to the first power is just going to stay. So it's just going to stay a -3 or a 3 in the denominator. We've got a purple v here. It's being raised to a negative power. It's in a numerator. So what we're going to do, we're going to bring him down to the denominator, and it's going to stay a positive. Or it's going to stay a 1, but now it is going to be a positive. And lastly, we've got u squared. He's positive. He's happy. Leave him alone upstairs. Don't touch him. So we've got u squared, or we have a negative u squared over 3v, and it looks like, well, A has that result for us. Again, don't get discouraged that we have the negative downstairs. Again, the whole fraction is just going to be your negative. All right, those are your exponent rules. Again, more importantly, there were 3 rules to take care of. Multiplying bases, add the exponent. Divide the bases, we subtract our exponent. And then powers to powers, we multiply the exponents. All right. Let's simplify some radicals. I'm just going to do, let's do number 12. All right, very, very similar procedures here. Again, there's not a lot you can do between coefficients and different variables, so we just got to break it down piece by piece. So this, we are simplifying a square root, right? This is a 2, so we need to pull out pairs. Again, we've got to find those perfect squares that hang out in 128. The best way, I think, or the most efficient way to do this, let's start with our factor tree. It's an even number, so I'm just going to cut it in half. Definitely helps to probably have a calculator hanging out. Mine will turn on. There we go. So 128 over 2 is 64. I know that 64 is 8 times 8. The better off you know your perfect squares, the easier these do become, because we can keep breaking these down in 2s and 4s, but understand that I've got a pair of 8s. Okay, so I'm not really going to mess with this any further because I know this can be simplified with an 8. So I'm going to go ahead and pull out that pair of 8s. And it's got a loner 2, or 2 is going to stay in the house. So one benefit of multiple choice is, always double check your answer. And all I had to do there was simplify the 64 to say 8 and 2. Only one result had the 8 and 2. So you don't really have to spend a lot of time manipulating that guy. But let's go ahead, just for the sake of what's going on, let's talk about it a little bit more. We have x to the third Remember with variables, there's only one decision to make. Is it even or is it odd? Well, 3 is an odd number, so 1 is going to stay in the house. If I take 1 away from 3, now I'm left with x squared. Well, divide that by 2. How many pairs do you have? Right, 2 divided by 2 is 1. There is 1 pair remaining. And then lastly, the y, it's just to the first power. That's an odd number. There's nothing left we can do about it, so it's just going to stay in the house. And we knew that the answer was going to be D just because of the 8 and the 2, because we broke down to 128, but we can see the variables as well. All right, let's go ahead and let's look at 11. It's not a big deal. So 256, we'll notice these radicals, 3 of the radicals don't have anything inside of them. Actually, B doesn't even have a radical. So maybe one thing I'm going to check to see, is 256 a perfect square? If you know what it is, good, move on. But it is a perfect square. 16 squared is 256. So what that's going to create, since it is a perfect square, there's not going to be a number in the house, right? Square root of 256 is a perfect 16. Right? The square root of, I don't know, more simply put, square root of 25 is 5. It's not 5 root 5. It is, or the square root of 5. It is literally the number 16. So if you want to think about it, actually, we can put a 1 in there, but we don't have to do that. Variables, we have m to the 4th. That's an even number. So if we pull this out, m to the 4th. Even, remember, all we got to do is even, divide by 2, right? Cut them in half. We have 4 divided by 2 is 2, so we have 2 pairs. So I'm going to pull out m squared. Nothing comes in. It was a perfect square. And my n here, let's look. I have n to the 3rd. Again, 3 is an odd number. 1's going to stay in the house. If I take 1 away from 3, now I'm left with 2. Same thing we just did over here. Cut it in half. 2 over 2 says we have 1 pair. So double check our answers. 16m squared n, radical 1n. And it looks like A has a result for us. The only other thing that isn't on this study guide is what happens if we have to simplify something that has a 3rd root. Just remember that these are square roots, so it's pairs or 2. The only difference is now that we're talking about a cubed root, instead of pulling out pairs, you need to pull out thirds. So you need to pull out terms of 3. All right, reach out if we need help.